If you remember, in the last video, we put together a problem-solving method for inclined planes. And it revolved around components, right? Especially components of the force of gravity. So in this one, we're going to add friction into the mix, though we did have a question with friction last time as well. It's just that we didn't actually have to calculate friction. It was just told to us. And in this lesson, we're going to add in that expanding into the formula of friction that we've used in other times. We need to remember the two types of friction, static and kinetic. So static friction is the force of friction that's acting on an object that is being attempted to be pushed. It's an odd way of saying that. Someone's attempting to push an object. Static friction is pushing back on it until you actually get that object moving. Okay? Once you've exerted enough force to get the object moving, then kinetic friction takes over. And the difference between the two is the coefficient of friction. So getting an object to start moving is harder than keeping it moving. And so the coefficient of static friction is higher than the coefficient of kinetic friction. Okay, hopefully that is all review from grade 11. So let's jump into an example here. A 50 kilogram skier is pulled up a 20-degree slope at a constant 5 meters per second. I see the word constant. That's usually important. If the coefficient of friction is 0.2, what is the tension in the rope? So our situation is as follows. We have a 20-degree slope, something like that. We've got a skier who is keeping perfect form by keeping their legs utterly straight. Not perfect form. And then we've got a force of tension that is pulling up the slope, and we've got a force of friction that is pulling down the slope. Okay, so this is tension, and this is the force of friction. And it says that it's a constant 5 meters per second that the skier is experiencing. And so when I see constant 5 meters per second, I also see acceleration equals 0 meters per second squared. Right? Constant velocity is the same as zero acceleration. The other thing that tells me is that all the forces in the x direction must balance out. Right? Because an unbalanced force in the x direction would cause an acceleration. Then we'd have a non-zero acceleration. So already I can jump straight to the force of friction should equal tension. Okay, I can go right there. You'll get used to that. If you still want to start with F net equals ma, which is a totally valid thing to do, we're just going to say that the acceleration is 0 meters per second squared. And so, get my vector symbol in there. So then F net is tension minus the force of friction, and that equals 0 newtons altogether because my acceleration is 0. And so then I would add friction to both sides, and I'd end up in the exact same place as I just started. Okay, so starting with F net equals 0 in this case is just as valid as jumping to this balanced forces situation here. I will accept both of those things. Now, it doesn't tell us what the force of friction is. It also doesn't tell us what the tension is. It's asking us for the tension, so that is hopefully obvious. But that does mean that we're going to need to actually calculate the force of friction. And it gives us the coefficient. It does not tell us the normal force. And so we're going to need to put in the normal force there. We're going to need to calculate the normal force. Last year, whenever this happened, we did this. This is equal to the coefficient times mass times 9.8. That is not valid in this particular instance. In fact, it is only this step we just did here in grade 11 is only valid when you are on a level surface. If you are not on a level surface, then the normal force is not the same as the force of gravity. We'll have to do something else to figure that out. So, first of all, let me get rid of this since it's all wrong, and then we're going to draw our force of gravity triangle. So here's force of gravity total, and then we get FGY or FG perpendicular there, and on the bottom we get FGX or FG parallel. And we know that this angle in here is 20 degrees because that is the same as what this angle is. Whoa, that's a terrible level surface there. It's 20 degrees all the same though. Okay, so that angle is still 20 degrees. The normal force, let me get even a different color here. I'm going to go full rainbow. That's the normal force. It's perpendicular to the slope, right? Normal means perpendicular, so it's got to be perpendicular to the slope. And because this skier is not being thrown off the slope or sucked through the hill, that means that the y forces must balance out. Okay, so the normal force is kind of an upward y force, and FGY is its downward opposite. And so what we can say is that the normal force is equal to FGY. Okay, that is valid always, whether it's on an inclined plane or not. On a non-inclined plane, the force of gravity is pulling straight down like this. That's also FGY. It just happens to, there happens to not be a difference between just total force of gravity equals mg and FGY. Okay, our formula for FGY has always been mg times the cosine of whatever the ramp angle is. And if we have a ramp angle of 0, which would be a level surface, cosine of 0 is 1. And so then mg times 1 is just mg, right? So this FGY formula, mg cosine theta, is valid in all circumstances. And it's also what we're going to need to use right now. So coefficient times mg cosine theta is equal to the tension. So this is our new formula for the normal force on an inclined plane specifically. Okay, you can remember that if you want. You can also derive it each time because you need to remember that the normal force is equal to the force of gravity in the y direction. Okay, so now we've got 0.2 is the coefficient times 50 kilograms times 9.8 meters per second squared times the cosine of 20 degrees. And all of that together is equal to the tension. Unnecessary bracket. So when we calculate all that out, you get tension is 260 newtons up the hill. Okay, so the only difference between this inclined planes question and the previous ones was that we needed to actually calculate the force of friction over there. But the force of friction formula is not the same as when it's on a level surface. We kind of took a logical leap when we were working with level surfaces to say that the normal force is the same as the force of gravity, when it is only true on a level surface. Now we are not working with level surfaces, and so we need to modify that friction formula a little bit. Example number 2. An object is placed on a 25-degree incline so that it has an initial velocity of 0, placed at the top of the incline. If it is 15 meters from the bottom of the incline and the coefficient of friction is 0.15, how long does it take to reach the bottom? 25-degree incline, like that. Object is placed at the top, right there, so that the distance between the object and the bottom of the incline, this distance here, is 15 meters. So it tells us a whole bunch of stuff about the forces acting on it. Well, it doesn't tell us a whole bunch of stuff about the forces acting on it, but we could figure out a bunch of stuff about the forces acting on it. Okay, so we're supposed to figure out how long it takes to reach the bottom of the incline. That's change in time. And it tells us its displacement is 15 meters. And its initial velocity is 0 meters per second. So it on top of the force stuff that it's telling us a bunch of kinematic stuff as well. And so we're probably going to need to use kinematics equations in the end to figure out what that time is. But it doesn't give us enough information to start out with to figure out what the time is. Okay. The other things that it tells us the coefficient of friction is 0.15. That's a dynamics thing to tell us. That's a force thing to tell us. And that's it. So what I want to do is figure out the acceleration. Okay? Because if you remember, one of our kinematics formulas was like this. Displacement equals v1 change in t plus half a change in t squared. And so if I knew the acceleration, I could solve for t, and it would be especially easy because v1 is 0 meters per second. And so that makes this whole term just get cancelled out. And so then solving for my change in time is far easier. I don't have to solve a quadratic or something like that. Though maybe there will be some that you will need to solve as a quadratic. Anyway, so if I could figure out the acceleration, then this would be not a big deal, right? So I need to somehow figure out what the acceleration is. That I'm going to get that from F net equals ma. Okay, I can get my acceleration because I have some force stuff that I can use. Okay, so let's split F net into its pieces. We know that FGY is involved here, as well as FGX. We know FGY is involved because of the normal force, and we're going to use that in the force of friction. So there's FG, that's sort of down, and then we've got FGY and FGX. And then we also have the force of friction. The force of friction is this time pulling up the ramp. The force of friction is pulling up the ramp because we know that the motion is going down the ramp. This is the force of gravity. There's nothing else that's pulling the box down the ramp. It's just going to be FGX that's pulling the box down the ramp. We're also going to need to know FGY because of the force of friction thing. So it's really only FGX and the force of friction that are involved in this acceleration. So that's what we're going to put inside F net. So here we go. FGX is down the ramp minus the force of friction, which is up the ramp, equals ma. But it doesn't tell me the mass. Well, let's just keep going. I think I'm doing this right, but let's see here. So FGX is the sine, right? So it's mg sine 25 degrees. The force of friction is the coefficient times the normal force. And if we remember, the normal force is the same thing as the force of gravity in the y direction. And so that's mg cosine 25 degrees. And together those things equal ma. Now, can you see what I see? There's mass in every term. There's mass there. There's mass there. There's mass there. So I can divide the entire thing by mass, and I don't even need it. So the question doesn't tell me what the mass is, but if I expand my entire formula into its pieces, then I can see that mass is irrelevant to this question. So it turns out I did know what I was doing. So we end up with g times the sine of 25 degrees minus mu times g times the cosine of 25 degrees, and that will give me the acceleration. So when I calculate that out, I get 2.809 meters per second squared. Now, ideally, you don't want to really round in the middle of a question, and so I'm going to either keep that number in my calculator to use it later on, or you can not calculate a, and you can just keep this entire expression as your a value. Now that can be a little bit annoying for typing it into your calculator later, and so I understand if you want to stick with the 2.809. Just keep a good number of decimal places so that you don't round oddly. Okay, so now we have our acceleration. So now I see that displacement is equal to half a change in t squared. Okay, I showed that previously from our kinematics formula on the left over there. So now I'm trying to calculate time, trying to solve for time, so I'm going to remove the half and the a from the right side of the equation, or rather I'm going to move it to the left side of the equation, and then square root. Okay, so t equals the square root of 2d over a. Think about that for a second, in case that doesn't make sense. 2d over a. Okay, I was dividing by a half and dividing by a. So it would have been d divided by half a. That also works totally fine, if that's how you want to leave it. But dividing by a half is the same thing as multiplying by 2. And so I get time is 2d over a. And so when I put in my 15 meters, because that's the length of the ramp, and my 2.809 meters per second squared, I end up with 3.3 seconds. That's how long it takes to go down the ramp. So sometimes you will need to put in all your terms into your formula, expand them all into their full formulas, and then try and do some sort of algebra in order to figure out what you need to in a question. Because you could see that in this case you couldn't calculate the force of gravity x, and you couldn't calculate the force of friction. Those are two things that you didn't have enough information to figure out, and so you had to actually calculate it. You had to calculate acceleration by expanding everything and then doing some canceling first. Okay, so doing your algebra first is often a good idea.